Good morning, children. Today, let us start molecular orbital theory. Okay, children, what is that? Molecular orbital theory. First of all, let us see why we have to study this theory. Now, there are three questions are there which will not be explained by valency bond theory. The first point is, now in all the diatomic gases, for example H2, two atoms they combine together to form H2, and we will write all the gases in the form of the diatomic. What is the meaning of diatomic? Two atoms they combine together to form molecule. So all the gases exist in the form of diatomic, H2, O2, N2. Is it clear, children? But all the inert gases they exist in the monoatomic state. What is the meaning of monoatomic? Now only He and Ne. Why not He2? He2 does not exist. What is the reason? Why all the gases, inert gases, they exist in the monoatomic state? Only inert gases exist in the monoatomic state, but the other gases they exist in the diatomic. Then you approach the valency bond theory. Valency bond theory did not answer to the question. Okay, that is the drawback of the valency bond theory. The next drawback is nitrogen and oxygen both are covalent compounds. Oxygen is having double covalent bond and the nitrogen is having triple covalent bond. In spite of both the molecules are having covalent bond, but O2 is paramagnetic. O2 is paramagnetic. I hope you know the meaning of paramagnetic. I already explained in the previous chapters. What do you mean by paramagnetic? The molecule is attracted by the magnetic field, whereas N2 is repelled by the magnetic field. Okay. O2 is attracted by the magnetic field, N2 is repelled by the magnetic field. What is the reason? Again you approach the valency bond theory. The valency bond theory could not explain this question. So the second drawback of the VBT, that is valency bond theory. The third question, children, oxygen is highly reactive, whereas N2 is chemically inert. So what is the reason? Is also drawback of the valency bond theory. So these three are the questions which were not answered by valency bond theory. So therefore, scientists they introduced a new theory which is known as molecular orbital theory. Molecular orbital theory. Now according to this theory, two atoms when they combine together, take for example hydrogen. Now hydrogen, how the molecule is formed? By the union of two hydrogen atoms. Two hydrogen atoms they combine together to form H2 molecule. But simply we say, children, before the introduction of the MOT, the short form is MOT. MOT, molecular orbital theory. Before the introduction, simply we say two hydrogen atoms they combine together to form a molecule. Two hydrogen atoms they combine together to form a molecule. But according to the MOT, molecular orbital theory, when two atoms when they combine together, so the atomic orbitals they combine together to form molecular orbitals. You know, I think students, what are atomic orbitals? Now hydrogen is having the atomic number 1, the electronic configuration 1 is 1 of one atom, 1 is 1 of another atom. They combine together. These are called AOs. AOs means atomic orbitals. So they combine together to form MOs. MOs is molecular orbitals. The number of formation of molecular orbital depend upon the number of the formation of the AOs. Since there are two AOs are there, so two MOs are formed. Now, the MOs which are formed, one is called bonding molecular orbital. Now children, please pay attention from here. This is a new topic for you. One is bonding molecular orbital and second one is anti-bonding molecular orbital. Now, anti-bonding simply we represent it with a star. How will you pronounce? Look at the board. First one, bonding molecular orbital. Now the star is pronounced here as anti-bonding molecular orbital. Is it clear, children? So if there are three MOs are there, three AOs are there, three MOs will be formed. Four atomic orbitals, they combine together to form four molecular orbitals. Clear, children? Now, one is of one atom, one is of another atom. What kind of overlapping? Head-on overlapping. Sigma bond is formed. So the two MOs which are formed, one is called sigma 1s bonding. Simply we have to pronounce like that. Now the second one is sigma 1s anti-bonding. So to represent the anti-bonding, we have to write in this way. Sigma 1s bonding, sigma 1s anti-bonding. So one is of one hydrogen atom, one is of another hydrogen atom. They combine together to form two MOs. That is two molecular orbitals. Sigma 1s and sigma 1s. Now since there are two electrons are there, the capacity of the each orbital is 2. So the two electrons enter into the bonding and anti-bonding is empty. Okay children, clear? So now s orbital already we discussed in the chemical bonding before. 1s orbital of one atom, 1s orbital of one atom, head-on overlapping. This is the sigma bond is formed. Here there are two atomic orbitals are there, so two molecular orbitals are formed. So sigma 1 is to bonding and sigma 1 is 0. Next is children bond order. What is bond order? Bond order is equal to number of electrons in the bonding minus number of electrons in the anti-bonding divided by 2. So that becomes 2 minus 0 upon 2 is equal to 1. Clear children? Since hydrogen, the bond order is coming to be 1, so hydrogen molecule is having a single covalent bond. It is matching with the covalent bond theory, covalent bond theory. Clear children? Now next is, I will explain how the AOs, they combine together to form MOs. If you take children nitrogen atomic number is 7. One atom of nitrogen, one atom of nitrogen. They combine together to form N2 molecule. 7 plus 7. Total number of electrons are 14. Now, these 14 electrons we have to arrange in the molecular orbitals. Now here, what is the electronic configuration? 1s2, 2s2, 2p3 of one atom plus 1s2, 2s2, 2p3 of another atom. Now look at the both children. 1 is of one atom, 1 is of another atom. They combine together to form two MOs. Sigma 1 is to bonding, sigma 1 is to anti-bonding. Okay. Now sigma 2 is to bonding, sigma 2 is to anti-bonding. Now p orbital, pi to px is equal to pi to py, then sigma to pz. Okay. Now here each orbital is having 2 electrons, so 14 electrons are over. Clear, children?